Yes, welcome back to our next class. In today's class, we are looking at this question. Let's look at what we have on the board. We are looking at chemistry question. The test question 025, 026. Let's see the question. The question says, silver is a valuable byproduct in the industrial extraction of lead from its ore if the half cell reaction is given as, of course, this is the half cell reaction. As you can see, this is the half cell reaction. And then, of course, this is the silver ions plus electrons to give us what? Silver solid. Of course, this one is called the potential. And this is the value for the potential with respect to what? The silver. The same thing applicable to what? Lead. This is lead at the ion state, electrons, 2 electrons. They give us what? Lead at the solid state. And then here is the potential for what? Lead. And then the question says, write the balanced cell reaction. Write the balanced cell reaction. Then the second part says, calculate the what? Change in G. And then when we are talking about change in G, we refer to what? The free give energy. Okay, let's see how we can resolve this. Okay, let's do solution. Let's see how we can resolve this. Solution 1. Solution I. Solution I. Write the balanced cell reaction. So for you to write this, of course, you need to bring out these two parameters, these two equations. So of course, let me say this is Ag plus, that is my silver in ion state, plus what? Electrons. You give me what? My silver in what? Solid state. Of course, I will name this guy to what? Equation 1. Equation 1. And then, of course, this one is what? My lead in ion state. Etios plus what? 2 electrons. You give me what? My lead at the solid state. Let me name this guy what? Equation 2. That's equation 2. So we are going to resolve this equation 1 and 2 to give us what? The overall equation for the what? For the reaction. So let's see. Of course, we have to resolve this. Check whether the electrons and the two equations are balanced. If they are not balanced, try to balance the electrons on the two equations. Of course, if you look at equation 2, you have how many electrons? 2 electrons. Equation 1 is how many? 1. So what do we do? Multiply 2 to equation 1. So equation 1 times equation 2. Electrons in equation 2 times what? Equation 1. So here is plus. Of course, we have it to equals plus what? Electrons. So give us what? Ag solid. So this 2 is multiplied and everything inside the bracket. So this should be resolved to 2Ag of course plus here is my Atios. Atios plus 2 electrons because of the 2 multiplied to give me 2Ag solid. So this is my new equation 1. Equation 1. Because I'm trying to balance the electrons. So of course, if you now check, compare equation 1 and equation 2 now. Electrons here is 2. The here is also what? 2. So since we have 2 electrons on the 2 equations, of course, check. If you check the equation, electrons in equation 2 is at the reactant side. Whereas the same thing applicable to what? The equation 1 is at the reactant side. So what do? We need to reverse one of these equations so that we have the electrons in the opposite side so that we can cancel out the electrons that are the same. So let's see. Let's reverse equation 2 from this guy. Let's reverse equation 2. Equation 2 says Pb 2 plus Atios plus what? 2 electrons will give us what? Pb what? Solid. According to this is equation 2. So I'm reversing equation. Yes. We have that this is silver. From here, since we have here to be 2 electrons, it means we need to balance what? This our equation 1, which I've done that. Which is this 2. It means the 2 is multiplying everything inside the bracket, which affects both the ions and what? The atoms present. The ions and the atoms present. So in this case, we now compare equation 2 with equation 1. If you notice that the electrons are the same, if you check, the electrons are what? The same. But you can't cancel out the electrons because the electrons at equation 2 is in what? The reactant side. The same thing applicable to what? Equation 1. The same thing applicable to equation 1. So what do? We need to do what? Reverse equation 2. Reverse equation 2. So if you do that, that will give us what? Pb solid. Will give us what? Pb2 plus. This will be our Atios plus what? 2 electrons. So in this case, since we are reversing equation 2, We have that electrons here is opposite with electrons here. So what do? We can now cancel out these electrons. The electrons can now cancel out. Then we take our overall equation. So overall equation will now give us 2Ag plus of course this one with this one plus PV solid. PV solid will give me this one plus this one plus 2Ag solid plus what? PV2 plus aqueous. And then of course, if you want to know whether the equation is actually correct and balanced, what do? Check the electrons on the reactants, compare with what? And the product. So we have how many electrons here? Of course, these two affect the charge, which is what? 2 electrons here. And then we also have what? 2 electrons here. Which means what? Equation what? Balance. So of course, this is our overall equation for this particular question 1. So let's go for question 2. Question 2, II. Of course, this II. So we should find what? Change in G. And then we know that change in G, because you have to find change in G equals to what? Unknown. And then we know that what? Change in G equals to what? Minus NF E cell. Where this E cell means cell potential. This guy means cell potential. And then this my guy here is what? My Faraday constant. And then N is what? The numbers of electrons loose or gain. And then we know that our F, Faraday constant, is given to the what? 96500 farad. 96500 coulombs. 96500 coulombs. And the number of electrons loose or gain, which is this, the number of electrons present in the two equations. We have 2 and 2. Those are the electrons that was cancelled out. This N. And then for this E cell, of course, for us to get this E cell, we know that E cell equals to what? E cathode minus what? E anode. Either you use this one, or you can say E ox plus what? E red. Any of the two formula you are using is still the same thing. So how do you get? So for us to use this one, what do? We come to this cell potential, because this is where we are going to use these values. This is where we are going to use this value. You come to this value, check the value that is greater than. Then the greater value give you what? The cathode. Then the smaller value give us what? The anode. So if I'm using this one, of course, this value is greater than this one. So I'll pick this one as the cathode, then pick this one as the anode. Then if I'm using this one, if I'm using this ox or red plus red, what do? I will come to this overall equation. I'll come to overall equation. Let's see. This guy is plus 2. From plus 2 to what? 0. That's from this guy to this guy is what? 0. From 2 to what? 0. It means this what? This is my what? Red, because it's what? Reducing. And then from this guy to back to this guy is what? From 0 to what? 2. It means what? Oxidation. That is what? Increasing. It's increasing, because we know that oxidation is defined as what? The increase in what? Oxidation atomic number. Whereas the reduction is defined as what? Decrease in what? Atomic number. So if you check, there's a decrease from 2 to what? 0. Check this one. There's an increase from what? 0 to what? To 2. So if I want to compute this one, so in this case, it means my oxidation is what? This guy. 0.13. And then since I reverse the equation, it means this sign must also be what? Reverse. So if I'm using this one, same thing. So of course, but let me just go with this man and go my way. So that will give me what? This cell will now give me 0.8 minus into 0.13. All in what? In both. That will give me this cell. Will now give me, of course, subtract this man and add this man. I have what? 0.93 volts. That's the answer. And then for us to get our change in G, since we are counting this, that means our change in G will now give us what? From this formula, N is what? Number of electrons loose or gain. From the equation, we have 2 electrons. That will give us minus 2 of what? F 96500 of our E cell, which is this what? 0.93. Of course, change in G now give us. So let's see if we multiply. Let's see what we are going to obtain. Let's see. 2 times 96500. times 0.93. Of course, we are having our change in G to what? Minus 17949 kilojoules per what? Per mole. That's what we have as our change in G. This is the last answer for this particular question, because in the last question we asked to find what? Change in G. So this is where we arrive. For us to determine whether this equation is spontaneous or not spontaneous, you check. If you notice that the sign of the change in G is what? Negative. Of course, that implies that our G is what? Spontaneous. So this is where we end our class for today. Stay informed so that in our next